And to complete the lecture 2 with full knowledge that is necessary to create some basic Python scripts, let's talk about basic input-output operations in Python. By now you should know how to implement a program in Python using imperative style of programming. That is, by providing detailed step-by-step instructions on how to convert input data into output data. One crucial piece here is still missing though, that will limit usefulness of your programs, and that piece is the ability for the program to actually take different inputs from outside world and provide data dynamically. We already have constants in code, or so-called hard-coded data, to provide inputs to our problems. This works well for simple programs written in Jupyter Notebook, but for other software, you will need to implement at least some form of interaction with external data. There are three main options for you to choose from: data provided by or reported to user, data that is read from or written to local file, and data that is accessed from or written to external network resource, database or API. We will discuss the former two in the next lecture, but in this one it is crucial to address the bare minimum. That is the way to enable program to read data from user input and report it back to user. We have already used print function that writes data provided to it as arguments into what is called standard output of the program. In case of Jupyter Notebook or IPython, standard output is displayed right after the cell in which print was called. In case of standalone Python script, the standard output goes directly into the virtual terminal from which you have executed the script. Print can take any number of arguments, and it will apply default formatting to the data. The default formatting is actually provided by each object itself via __str___ method. For example, we can call this method on a floating point number 5.0, and we will see string representation of 5.0. Similarly, we can call this method on a module that we have imported. And as you can see, it returns some self-reported string representation of that module. We will discuss special methods of objects such as this str method when we will talk about object-oriented programming in Python. For now, it is enough that you know that you can take pretty much any object except for integer numbers and call a str method on it to get its string representation. And the results of this function are exactly the same as calling str and passing whatever object we want to inspect in such way as an argument to str. To get data into the program, you can use input function. If called without arguments, this function will present an input field to user that could be used to enter any string sequence completed by typing enter. In case of Jupyter Notebook, this query will be placed right after the cell in which input was called. And in case of normal script, the user will get a standard serial prompt. Input also takes the optional argument that specifies the prompt or the hint text about what kind of input the program expects from user. For example, let's make a simple greeter program. So first the program asks for something, and then it greets us with whatever string that we have typed in. Let's make it a little bit more. Let's add the questions that we want users to answer. As you can see, we have successfully managed to print out this "what is your name." We could have done the same with just printing it right before the input. And pay attention to the /n sequence at the end of the string. This sequence turns into a new line character. This is a special ASCII code that tells terminal that there is time to create a new line and start inputting on the new line. If this character will not be present, we will end up typing name on the same line, which may or may not be desired for your program. The second line uses f-string formatting to join the name entered by the user with the rest of the greeting. Note that figure brackets that define place for variable. Inside those you can write both variables, constants, and even simple Python code like equations. Let's write some like this. And as you can see, it correctly computed, formatted, and printed out that the sum of 3 and 2 is 5. You can use alternative formatting syntax. The three prints here are exactly equivalent. As you can see, they print out the same data. And the upper one is the latest, and then the middle one is has been introduced in Python 3. And the %sign syntax for formatting is actually the oldest one that dates back to Python 2. And you can also specify formatting options for floating point and integer numbers, such as the number of decimal places, number of significant digits, absence or presence of leading and trailing zeros. And if you want to learn more about this, please refer to Python documentation for syntax of these operations. Now finally, let's make a simple program that will run until user terminates it. To do that, we will need to use the same while true syntax that we have used before. And we will ask user for input on each stage. And we will save it into variable input. And then we are going to test if imp upper equals to q, then we break out of the loop. Now we can type anything until we type single q or capital Q. One comment about this upper function: this is a property of any string, and this can be used to convert any string from its lowercase version to its uppercase version. For example, if we're going to use our string here as input and apply upper to it, you can see that all lowercase characters have been turned into their uppercase versions, and numbers stayed the same and special characters stayed the same. This is a very convenient thing when you want to organize especially variable or case insensitive input from the user.